Hi, review time today. What we've got here is this fairly new model Chinese LCR meter from a company called Applent, and a symbol that's possibly slightly reminiscent of another test equipment company that may spring to mind. I've had a sort of look at their product range. They basically focus on the sort of second level of sort of slightly more specialist gear. They don't do any scopes or meters or anything, but they do things like LCR meters, capacitance meters, resistance, the slightly less common range of test equipment. They do have a pretty wide product range. There's three models of this. There's the AT825 and 6. The difference is the frequency range. The 824 does 100, 120 and 1 kilohertz measurements. The 25 adds 10 kilohertz and the 26 adds 100 kilohertz. The 826 is quite a lot more expensive. The other slight difference is the high frequency ones will go down to lower capacitance and inductance ranges, but other than that they're pretty much the same. It's got this colour screen, but it's also a touch screen, which I think is pretty superfluous, because you also got the touch screen doesn't really do much more than these buttons do. There's a few, you can sort of select some of these fields, but this text up here is sort of sufficiently small that it's of, I think, limited use. I'd probably rather have a hard plastic screen, because obviously being a touch screen, it's a fairly soft plastic, so it's maybe liable to get a bit scratched. Fairly reasonable feel, rubber, pretty much a standard rubber keypad. It's got usual 4mm connectors plus the 2-wire contacts for sort of plugging component leads directly into it. It also comes with this. This is a 4-wire set of clips, a set of proper Kelvin 4-wire clips, and this just sort of plugs in and latches like this. The contacts on there, this is PCB material. Remains to be seen how hard the gold plating is on that, so how durable it is, but the clips sort of seem fairly reasonable. Fairly basic casing. On the top you've got mini USB, this is for data out, and they do give you all the information on all the protocol that it uses, and I think some software you can download from their website. Mains adapter for charging. Unfortunately it won't charge through USB. Now that's one annoyance really, because on an instrument like this is the sort of thing that you use sort of just occasionally, and it's annoying that you just can't USB charge it, so it's yet one more charger that you've got to have and remember which one's which. This is a 9-volt charger rather than a 5-volt. It uses two lithium batteries rather than a single one, so it would need a booster charge from 5 volts, so that's a bit of an annoyance. This mains adapter, it comes with this 2-pin thing. It did actually come with a like a travel adapter with various pin things, but I was taking it apart and it sort of fell to pieces, and I couldn't be bothered to figure out how to get it back together again. But the standard mains adapter, it feels extremely light. I'll have a look inside of that, because obviously any Chinese mains adapter, you've really got to have a look inside to see what the safety is like. And on the back it's got the usual tilting thing. It tilts, there's two different angles. There's that flips round, so it'll tilt at sort of that angle or further up, and it's reasonably solid. I mean, it wobbles around a little bit, but it's just about usable. Comes with a fairly quaint sort of ring-bound manual. The English isn't too bad. There's no sort of really serious Chinglish in here. There's quite a lot of detail. It's photocopied pages, but it does seem to be a fairly comprehensive manual. Get this test report, which is purportedly of the actual instrument, showing the actual measurements, although, I mean, to be honest, some of these look suspiciously bang on, these calibration measurements, so it'll be interesting to actually compare another one to see whether this is actually an instrument specific thing, or whether they just duplicate these. Maybe I'm just being a bit too cynical, but packing message tells you what's in the box. And this certificate of approval, warranty card, don't quite know what that's meant to be. And that's it. It comes in this sort of pretty standard box. There's no soft case or anything with it. Just a fairly standard box. Right, let's take a quick look at this mains adapter. No CE mark, no UL approval on here, so that doesn't bode particularly well. Just have a look. Claims to be 9 volts at 1 amp. Well, it's cheap sort of paper PCB. It's sort of reasonable amount of clearance. There is mains filtering on it, so it's, you know, it's cheap, but it's not ridiculous. I'd say it's, I think, just about acceptable. There is a fuse. I've never seen a fuse like that. A wire-ended glass fuse. Looks like a little bowl. So they have made a little bit of effort with filtering. So yeah, just about acceptable, I think, is probably the verdict on that one. Right, got the battery compartment on the back. Metal insert on the screws, and this is 2 lithium polymer packs in series. It's quite slim ones, and they just plug into a little thing, so that'd be easy enough to replace. I'm assuming they've got pack protection on there. I can't really see very easily. It's quite unusual to find packs of this size that don't. I don't think I'll bother untaping that. And these are 1300 milliamp hour. Again, these rear screws are going into brass inserts, which is good. You know, cheap soft tappers. And these bumpers on here are sort of vaguely soft, and the plastic itself feels like pretty sort of standard ABS. These are about sort of halfway between solid and the sort of soft rubber you get on things like flukes, so that they're sort of, they give a little bit of bump protection, but I doubt they give much protection if you actually drop the thing. Right, quite a nice little detail where the battery connector goes down. There's actually a little PCB with some sort of press contact, so the back just comes off without any leads hanging off, and that just goes down to this little PCB on here that plugs into the main board. It seems a slightly elaborate arrangement, but it means you can just take the back off without having to worry about the leads coming off. Foil shielding in the back. There's a spring contact on here to make contact with it, so that's quite nice. Well, internally it looks pretty well built. Really sort of decent PCB, quite a lot on here. Take a closer look. And up here, this is the main processor. This is a Nuvoton ARM processor. So obviously a fairly new design. One thing you quite often find in sort of older Chinese models is like really old obsolete processors, but this is a fairly up-to-date design. I've only noticed this, I don't know how long this has actually been on the market, but I've only noticed it fairly recently, so I think it's a reasonably new model. There's a connector up here. That may be perhaps a JTAG connector or something, because there's nothing that obviously plugs into in the unit. There's the beeper up here, USB socket. One thing I noticed similarly to the Regol is they seem to be almost going out of their way to not use Chinese parts. So for example, that's a Texas TPS for the power supply, and even like all the op amps and the run-of-the-mill stuff, they're sort of well-known makes, not just obscure no-name brands. The inductor there for the power supply. That's actually a constant current LED driver, so you know they're actually going to some effort to drive the backlight properly. I'm just using a resistor. And there's an analog devices AD5424 D to A converter here. Interesting, there's a CPLD here, there's an Altera Max 2 CPLD, which I wasn't really expecting to see in something like this. There's an unpopulated footprint here. That looks like it's almost certainly a serially squared prom. Looking at the pinout, there's the option for another crystal there, and you've got all the analog stuff down here. This is all just multiplexers and op amps. There's a couple of big film capacitors, one there, one under there, and there's a few unpopulated components, which I'm guessing this may be to do with the 100 kHz version. And there's an unpopulated thing that says VL, which is probably an adjustment pot. So I'll imagine this lot gets populated for the 100k version. And the sockets are actually on this separate sub-board here. It looks like it's got transorbs for protection. But generally sort of very, yeah, pretty decent build quality. Gold finish on the PCB. Pretty reasonable. Let's take a look underneath. There's not really anything at all on this button. There's the LED behind the power button that tells you when it's charging. There's the display, ribbon's just soldered down onto the PCB. Looking at the colour, it looks like it's 4-layer PCB, which is nice. And that's the top of the terminal board. If you look closely, you might be able to see there's some sort of shielding over the front side of that. And this does actually unplug, it goes into a little connector, so you can actually get that off. But pretty nice hardware wise, no real complaints about that at all. Looks like there is an option for a push button that they haven't populated on here as well. The sort of right angle push button. Not quite sure what that's for. Right, let's take a look at the power consumption. Switched off mode, 70 microamps, which is a little bit on the high side, but not too tragic with a 1.3 amp hour battery. That still corresponds to a 2-year discharge time, so I suspect they're probably running that DC to DC converter continuously. That's maybe what's taking that, but not a huge deal. So turn it on. About 116 milliamps. I think most of that's going to be the backlight. If we cycle through the backlight settings, it goes from 100 up to 150 milliamps. Now the manual says 8 to 14 hour battery life depending on brightness settings. That pretty much works out from a 1.3 amp hour battery. Right, so a quick play with this thing. Power up time is fairly reasonable. And well, you now I think my main issue is the user interface is a little bit sort of overcomplicated. I mean, for an LCR meter I sort of really want just 3 big buttons that say L, C and R, and then 1 button to get me into all the other functions. There just seems to be several different ways of getting to the same place, which means it can be a little bit confusing. So for example, you know, when it powers up, you really want it, all these on-screen touch buttons have the same function as the button below it, so the touch screen is sort of pretty superfluous. But for example, to swap to LCR, you know, you need to get into this menu here. You can actually, it is actually possible to get them on screen at the same time, but it's more than 1 button press from power up. So here we've got sort of C, L, R functions and the display at the same time. And it's got a second display, so depending on what you're measuring, you'll measure Q, ESR and various other obscure parameters, not all of which I would claim to understand. I haven't got much in the way of accurate inductors or capacitors, but I've got quite a few precision resistors, so I'll just sort of go through a few of these sort of randomly. This is a 5.01 ohm, 0.1%. This is a 4-terminal device, so we can use our 4-terminal Kelvin probes on it. Yeah, 5.008, which is 0.002 out, which is fine. This, believe it or not, this is a wire wound 1 meg ohm resistor, 0.05%. No idea where this came from. I've got a few of these, I can't remember where I got them. I've probably had them for a good 20 years or so. So 999.2, which is within spec, just. Another high value one. This is a 100 megs at 5%. 97, 98. Can take a little while to settle. One other thing I noticed, particularly on some of the other ranges, is it's not very good at suppressing meaningless figures. So when you're sort of messing around with the connections, now on the resistance it does, but on the capacitance I found that it does quite often show sort of completely meaningless measures that it should really suppress while it's sort of settling down and while it's making contact. What's this? This is 520k at 0.1%. Yeah, just about there. And this is a 0.01 ohms at 0.5%. So this is where you absolutely have to use the 4-terminal measurement, and again 0.01. That's fine. So it seems to be perfectly okay on resistance. So I've got a few capacitors. I've got a few polystyrene caps, which are probably about the most accurate ones I've got. This is 1 nanofarad at 2.5%. Again, that looks pretty close. And we've got 6.8 nanofarads at 2.5% here. I seem to have hit the display hold somehow. 6.8, yeah, it's just about. So without any accurate reference things, I don't know to what extent it's the capacitor versus the meter. Oh, there's a 1% one here. 3.3 nanofarad at 1%. Again, that's pretty much bang on. So 1 nanofarad, 2%. No, it's not, it's 4, the paint rubbed off. One thing I do notice, the auto ranging on this is pretty quick. Yeah, from one of the things that I find a bit annoying, for example here you're seeing it's showing -0 picofarads, which obviously is meaningless. Now the negatives might be useful if you're doing a relative measurement, but it really ought to just suppress that and just clip it to 0. But so if we just stick this 220 cap on there, the auto ranging is pretty quick. It's got a slow and a fast display mode. There seems to be a bit of a trade-off between accuracy and display speed, but if you put it on fast mode, it does make display update pretty quickly, which obviously would be quite handy if you're testing lots of different components. Just speed it up a little bit, but some of the measurements do get a lot less stable when you're doing that. But so the actual auto range and everything does seem actually pretty quick. It also has got a mode which will supposedly automatically determine what you're measuring, so it switches between capacitance. I assume what it does, it just looks to see if the dominant characteristic is capacitive, resistive or inductive. So resistor, yeah, it's getting confused, but 100 meg ohm resistor, yeah, I can forgive it being confused about what I want to measure when I connect a 100 meg resistor to it, I think. Let's try the 1 meg. Yeah, 1 meg, it sort of pretty much realises it's a resistor. Let's go and find some inductors. .58 millihenries, I think that's about right. This one isn't labelled, but I think that's I think from memory that's 100 millihenry. Yeah, that's pretty much bang on. So most of the things that I have here to test seem to be giving sort of pretty reasonable results. I think looking at that hardware, I think the basic performance is going to be fairly reasonable. I think it's just that the untidiness of some of the aspects of the user interface just are a little bit off-putting. One thing I don't particularly like is the fact that apart from the main and sub displays, everything else is in really small font. It's like, yeah, that's unnecessarily small. They could have made that at least 50% bigger to improve readability. So we take it out of auto mode. You've got secondary functions, which again there's auto, which I think all that does is it selects it according to what the primary function is. But so for capacitors, you've got DQ, ESR, and a few other things, which I'm sure if I understood maths a bit better that I might actually understand what all those did. So just switching between basic LCR modes once you're out of the menu is a bit annoying. Inductance, you've got again DNQ, ESR, so presumably with inductance that'll be the series resistance, I would imagine. So we go ESR 88 ohms for inductor that size. I think that's fairly plausible. It's a nice big toroidal power inductor. 488 microhenries, that's plausible for something this size, and obviously very low resistance, 0.09 ohms on that. Other functions you've got in here: language, English or Chinese, not surprisingly. Touch panel, you can turn the touch panel on and off and calibrate it, so you can actually completely disable it if you don't want it. Timeout for display dimming, auto power off, different times or off completely. Display brightness, which you can also control directly via this button here. And file, I think that's basically whether it saves the configuration when you turn it off and comes back the way it was configured last time, or whether you make it come back with a specific known configuration. And this is just all the various version information. I've got various other equivalent mode, not entirely sure what that is. I'm sure people that know more about LCR meters might know a bit more about that. The only other function has got a comparison function, so you can set up a nominal value and a tolerance, and it will give you a pass-fail. So if we set up, so this is one occasion where the keypad is possibly actually useful, and you can actually type a numeric entry. So if we do 5, but again it's perhaps a bit on the small side. You probably want a sort of stylus rather than a finger. So 500 microhenries with a tolerance of 10%. So that's showing the deviation, so it says -2.5% pass, and it's showing red for fail. So if you're just using this for quality control or batch testing components, it will give you a quick pass fail. What I would expect it to be able to do is to tell you where, yes, you can actually tell it to beep. I was sort of thinking, yeah, you can say beep on pass or beep on fail. So if we say beep on pass, so it's beeping because it's okay. So, and again, similarly you can do beep on fail. So we say beep on fail. So it'll just keep on beeping until it gets one that passes. But so one thing I do notice is that, yeah, when you're connecting, disconnecting, you often get like a garbage reading the first time. So for example here it's showing sort of some, as it's ranging, I'd really much prefer if it just blanked the display, because it's clearly a completely meaningless reading. So it's just it just confuses things, showing things that aren't actually that relevant. So here we start off, it's showing blank because there's nothing connected. As soon as you connect it, you seem to always get one garbage reading before the actual value, although you do get the value fairly quickly. It's just a bit distracting. I'd sooner it stayed on that until it got a little bit more stable. Right, now I've got a reasonable meter. I thought I'd actually just have a quick play and have a look at the characteristics of a few components. One thing I wanted to check is whether the thing like the ESR actually are giving meaningful readings. Here we've got just a cheap 85 degree capacitor in series with a resistance box. So that's, I think this box is a little bit intermittent, hence the bouncy readings. So if I add, for example, that's showing about 1.5 ohms ESR. If I add 10 ohms in series, again we're still getting the right capacitance reading. We're now seeing that 10 ohms appearing on here. So this thing can discriminate the resistive part of the capacitor, and at high values it gets a bit silly. Like if we go to 100, it's still showing a fairly reasonable ESR reading, but the capacitor readings going low, but that's pretty much to be expected. Right, now I've actually got a fairly reasonable LCR meter as opposed to this old one which I've had for years. Thought I'd just have just out of curiosity, look at the characteristics of a few different types of similar value components. So I've got a bunch of assorted capacitors here. This is an 85 degree electrolytic, just cheapo, bog standard, nothing at all exciting. showing sort of 32 microfarads, which, considering it's actually labelled 47, is a bit on the low side. That's got fairly high series resistance, about 0.97 ohms. There's a similar one. This is 105 degree. That's sort of 0.6. You tend to find that 105 degree ones tend to have lower resistance because they tend to be designed for things like power supply applications. This is a Panasonic 105 degree. And that's down to 0.3. That's much better. Going below that, you tend to start looking at other types, because electrolytics aren't particularly good capacitors, but because of their density, there's often not really much choice. This is a tantalum surface mount. That's about 0.27, 20 microfarads. So again, that's lower still ESR. But for things like high power, high current DC to DC converters, you tend to need to go to things like this. This is a polymer capacitor. They're very expensive on these, like about sort of 80-90p each, but the difference in ESR is very dramatic. If we look at that, that's 0.01 ohm ESR, and the size of that, I mean, some of that's probably just the leads. This is another polymer type cap in a more sort of familiar electrolytic shaped package. And that again, that's 0.02 ohms ESR compared to a similar sized sort of surface mount electrolytic. Again, that's 2.8, that's sort of a very small package. The other caps that have very low ESR, but again are very expensive and high values, is ceramics, and this is actually a 47 microfarad ceramic in a fairly fat 1210 package. And that's again down at 0.01 ohms. So if you've got a high power DC to DC converter, using the right type of capacitor on the output can literally be the difference between it working properly or being just completely unstable. And even capacitors of anomaly a similar type can actually have quite substantially different characteristics. What we've got here, these are two 1 nanofarad capacitors. The one on the right, the lighter colour one, uses an NPO or COG type dielectric, and the one on the left is an X7R. 1 nanofarad is about the point at which they tend to cross over in a given size between the NPOs and the X7R type dielectrics. Now, a lot of applications it doesn't really make any difference, but if we actually look at the characteristics, we'll see that the ESR on these actually is quite dramatically different. So if we look at the NPO, that's showing just under a nanofarad at 3 ohms. The X7R is 240 ohms. Now this can make a big difference in particularly things like tuned circuits, for example in an RFID application, where anything where you want to get a nice sharp sort of resonant tuning in an LC circuit. The difference between using an NPO and X7R can literally mean the difference between the thing working or not working. A few years ago I sort of got caught out on that. I was doing a project using sort of resonant tuned circuit for detecting proximity of metals, and I prototyped it and it worked all fine, and that then sort of built a few test boards and they just didn't work at all, and it took me ages to figure out that it was just a different capacitor that was making the difference. A quick play with some inductors. As you probably know, an inductor is basically a coil of wire, so I've got this little coil of wire here, measuring about 1.6 microhenries. You don't often see inductors though that are just coils of wire because it's not very efficient, so you tend to find lumps of ferrite. So if we put a lump of ferrite in the middle, we suddenly get a lot more inductance. So that's why they tend to wind on ferrites, except for like very, very, very high frequencies. But even with ferrite cores, even with ferrite inductors, there are some differences in characteristics. This is about a 470 microhenry, typical of the sort of thing you'd use in a little switching regulator. One property of inductance is the Q, which is sort of a quality factor. And this can be quite important if you're producing resonant circuits or tuned circuits. And it's effectively just how efficiently it circulates the, if you've got a capacitor and inductor in parallel to make a tuned circuit, the Q factor, the higher the Q, the sharper the resonance. And the way that inductors are mounted can actually have an effect. So for example, if I put this lump of copper next to it, you'll see that the inductance reduces slightly, but the Q reduces quite substantially, because what's happening is we're going from 42 down to 20 odd, because the copper is effectively absorbed, the magnetic field is passing through the copper, and that's setting up an eddy current which is actually absorbing energy in the copper. Now if we do the same thing with a toroidal core, because the magnetic circuit on a toroid is basically contained within the ring, it's far less affected by the presence of metal. So that's showing 58. If I stick that copper right next to it, there's hardly any difference at all to either the inductance or the Q. One thing of course that does make a difference is if you put a shorted turn around it. Just short that out. The Q completely plummets and the inductance goes down, which isn't often an issue, but if you're sort of maybe screwing it down or something, you need to make sure you don't get a shorted turn around the inductor. The other thing, which can very occasionally be an issue, one of the limitations of ferrite and other core materials is they'll only magnetise up to a certain point, at which point they saturate. So for example, if you're choosing an inductor for a switching regulator, its current handling capacity is not just the resistance of the wire, it's also the point at which the core saturates. And I can easily show this if I've got a strong magnet. If I put that magnet next to it, the inductance just completely plummets by a factor of 10 as it goes into saturation. So obviously, you could actually use this as a magnetic sensor, because the inductors are very cheap. So if you ever need to sense the presence of a magnet as maybe as an alternative to a reed switch, you could maybe just make a little LC oscillator and look for the change in frequency when there's a magnetic field next to it. Right, to sum up then, decent build quality, colour display sort of looks quite pretty, it's good contrast, but how useful it is a little bit marginal. Touchscreen I think is a waste of time, but you can ignore it. Price wise, it's not dissimilar to the Agilent range. It's a little bit cheaper. If you look at the Agilent U173 range, the specs, battery life are in the similar sort of league, sort of up to 0.2% in the best case, and that widens out as you get to the extremes of range. The sort of the accuracy specs and also the model specs. There's a 1K, 10K, and 100K version of this, as there are with the Agilents. Pricing on this, the only place I can find with prices is eBay. There's a couple of eBay sellers selling them. The 824, which is the 1K version, was £149 UK delivered. The 10K one was 189, which is this model. The 100K one seemed ridiculous. That was 363, which I think is ludicrous. If you look at the pricing on the Agilent ones, there isn't anything like such a huge price difference on the higher ones, but the 100K one, there don't seem to be as many of those around, so maybe those have only just come in and they've not sorted out their pricing properly yet. But so it seems fairly reasonable. Okay, the user interface is a bit messy, but to be honest, on LCR meter isn't really complicated enough or used frequently enough that that's going to be a major headache compared to something like, for example, an oscilloscope, which is a much more complex piece of kit that you're going to be using all the time. Where a bad user interface will get really annoying really quickly. I think this is certainly pretty tolerable. It could be better, but you can say that for pretty much any bit of Chinese kit. They just really haven't, most Chinese manufacturers just really haven't got their act together on the software front, but this is pretty acceptable. So yeah, fairly reasonable piece of kit. Pricing wise, it's a bit cheaper than the Agilent. Whether you want to save that bit of money for maybe the peace of mind of a bigger name brand, I really don't know. It's really up to you, but yeah, sort of not unhappy with this. I needed an LCR meter that was better than the cheaper one that I had, so I'm sort of reasonably happy with this. I think probably the biggest annoyance is the fact that it won't charge from USB, so I've just got another charger to lose, or not find, or plug the wrong one in and do something nasty. For something like this, you don't use it very often, so it's a bit of a pain to just have another different charger there, but other than that I think it's fairly reasonable.